6a. On 6a. Now, I can't teach you all of trig in 1 week. So we're going to touch on the most important topics that you'll need for calculus later on. Okay? The first thing that we're going to do is the unit circle. Okay, because you need to know what the sine of pi over 6 is. You're going to have to evaluate that when we do integrals later on. We're going to take derivatives of all our trig functions, and you have to plug numbers in and stuff like that. So let's recall the unit circle. I know that Mrs. Pfeiffer and I taught it a little bit differently than each other. I usually just memorize the first quadrant. So our angles are going to be in radians. So this is pi over 3.
What chapter is this in Ham?
This is chapter 4 in Ham. 4, 5, and 6 all went together. It was second semester. So at pi over 3, this is 1/2 rad 3 over 2. Okay? The angle in the middle is pi over 4. Pi over 4. So 1/4 of a pi. And that's the easy one that people remember. Rad 2 over 2. Rad 2 over 2. And I have my answers as rationalized, not 1 over rad 2. And then over here, I've got this angle, which is pi over 6, 1/6 of the pi, very small. And that would be, excuse me, rad 3 over 2, 1/2. Okay? And then we have special points along the outside parts, like, for example, this right here, which is at angle 0. That's the point 1, 0. Up here at 90 degrees, or pi over 2, that's the point 0, 1, and so on. Okay? And then the other thing that I teach is all saints trust Christ. All saints trust Christ. And you have your own little acronym. Did you learn a different one? Yes. We know that one. Yeah. I didn't.
No, it was Jeanette.
Someone else did. Yes, it was not me. I say all saints trust Christ, or all students take calculus. That's like the public school, probably over at GAR. That's what they're teaching. But what that means is all of our trig functions, when you evaluate them of any of these angles, they're all positive here. Only sine and its reciprocal, tangent, and cosine. Okay? All right, so then you're going to have to do things like number 1, evaluate. And maybe you don't need the unit circle, right? Maybe you evaluate. This pen isn't working very good today. So let's say that you want to find the sine of pi over 3. Okay? So all of your angle, or all of your points up here are always cosine of theta. That's the central angle in here. Sine of theta. So if theta is pi over 3, we go to the sine of pi over 3, and that would equal rad 3 over 2. Okay, on your calculator, it'll look like 0.866 something, but we never use our calculator for these. Okay, unless you memorize them, you have a nice teacher that lets you do them. So then, letter B, if I wanted to find the sine, bless you, of 2 pi over 3. Okay, what you want to do is you want to look and you go, okay, pi over 3, it's going to have the same value, rad 3 over 2, but it's in a different quadrant. So I have to decide if it's positive or negative. Well, what quadrant is 2 pi over 3? 2/3 of a pi. Remember, 1 whole pi is 180 degrees. 2/3 of a pi, you're in quadrant 2, and so your answer is positive because all saints trust Christ. Do you remember doing these? You have your own ways, probably, figuring them out. So how about if you needed to find the tangent of pi over 6? Remember, tangent, what's its quotient? Tangent equals what? Sine over cosine. So that's an identity that you should be pretty familiar with. Tangent is sine over cosine. Okay, so at pi over 6, that would be 1/2 over rad 3 over 2. You could flip and multiply 2 over rad 3. I think a lot of you would leave it as 1 over rad 3. I don't really like that. Rad 3 over 3. Oopsie. Rad 3 over 3. Okay? Remember, negative angles go in a clockwise way. So you're pretty good at those? Pretty good at unit circle? You remember all that stuff? Yeah? Okay, what about converting? Converting between radians and degrees. Radians. Yeah, no, we don't really. Yeah, that's the degrees, minutes, seconds. We don't use that too often, unless they give it to you, but I usually don't. Radians to degrees and vice versa. So all you have to know is your conversion. Do you know conversion factors? Like 12 inches is a foot, 5,280 feet in a mile. Okay. So radians to degrees, 180 degrees is equal to pi radians. Okay? So if we're going to convert, you want to use a conversion factor. So for example, number 2. 5 pi over 6. Okay? That's an angle measure in radians. It's in quadrant 2. Okay? But we want to find out what degrees it is. So we're going to do 180 degrees over pi radians. And then you just multiply this out. The pi's will reduce. 5/6 of 180 is, what is that, 150? 150 degrees. Okay? Definitely in quadrant 2. Do you know how much is 1 radian in degrees? 1 radian. That's pi radians. Pi radians is 180 degrees, but what's 1 radian? You know, pi radians is 3.14 radians, about. This is about 3.14 radians. Well, what's 1 radian? Well, let's use our conversion factor. 1 radian, and we're going to go times 180 divided by pi. Nothing's reducing, okay? So you go to your calculator, and you do 180 divided by pi, and 1 radian is about 57.3 degrees. It's not a nice number because it's in terms of pi along the way, so it's not going to be pretty. But you know what a radian is? Probably not. I don't know, maybe. So 1 radian is about 57 degrees, so that's probably about there.
3, right?
Yeah, 2 radians. 3 radians is just before pi radians, which is 3.14159, blah, blah, blah. So a radian is, we're walking around, it's this from here to here, this distance here is the radius. They're equal to each other. That's what makes a radian. I don't know if you knew that or even cared to know that. Okay, part B, arc length. Arc length. We have a formula for this, okay? I'll give it to you. That's not the formula. That is a formula, but that's not the formula. So let's suppose we have a circle, and we have a central angle, and we're going to call that central angle theta. Didn't you think it's weird once you got to trig, all these Greek letters came in? It's like, why? S is for arc length, and R is the radius. So the arc length of any circle is equal to its radius times theta, as long as theta is in radians. This won't work if you're in degrees. Did you know why a circle is 360 degrees? Isn't that weird to you?
It's divisible by 2.
Yes, 360 is divisible by a lot of numbers. 2, yeah, and how many days are in a year? 365. They picked the closest number that's divisible by a whole bunch of things. It's arbitrary. They actually just picked it, 360. Okay, anyways, I took the history of math. It was really good. Number 4. So let's go ahead. We're going to find the missing length or missing measure. Find the missing measure. You're going to need your calculator, so go ahead and get that out. I got mine handy. And let me say that we have angle, radius, and radius with a U, not an A. Radius and arc length. Okay, so I'm going to give you two pieces of the puzzle, and you have to find the third piece, okay? So let's say that the angle is 7 pi over 9. The radius is 5 inches, and the arc length is question mark, okay? We're going to fill in the blank, find the missing piece of information. So we're just going to use our formula. A couple things you need to make sure. Make sure your angle's in radians, okay, and then it'll work. So this is arc length equals radius times the length, or the angle measure. So S equals 7 pi over 9 times 5. Yeah, decimal's fine. Okay? We're finding the length of the arc that's being made here. We want it in decimals. 7 pi divided by 9 times 5. You should get about 12.2. Okay? All right, what if it's not in radians? Okay. Perfect. So let's say we have 100 degrees.
Can you do one where it's like 98.2 degrees or something?
Sure. Should we do that instead?
Yeah.
Okay.
Just like a really weird number.
Oh, okay. Yeah. 98.2 degrees.
Yeah.
Sure. Why not? This time the radius is missing, and the arc length is 20 centimeters. Okay. So before you can plug this into that, formula that I gave you, that S equals R theta, you need to convert. So we're going to take 98.2 degrees, and we're going to convert this into radians. So now we got to flip our conversion, because we did 180 over pi earlier. Now we're going to do pi over 180. So remember, these units, they'll cancel out, as you like to say. They reduce. And so you just multiply that out. 98.2 times pi divided by 180. Use your calculator, and you get 1.71. We can round to 2 decimal places. This is fine. 1.71 radians. Okay? So now to find the radius, we will use S equals R theta, or you can solve for R. So R equals the arc length divided by theta. So R would be 20 over 1.71. And if you left that number in your calculator, just go 20 divided by answer, and that'll give you an even better estimate. So then the radius turns out to be about 11.7 centimeters. Okay? All right, and then finally, one more of these. Let's say we don't know the angle measure this time. And the radius is 12 centimeters, and the arc length is 30 centimeters. Okay? Same idea. If we want to solve for theta, theta equals the arc length divided by the radius. So we would do 30 divided by 12. And you can just, put that in decimal form, 2.5. So 2.5 what, though? Radians, yes. And if they asked you to convert that into degrees, then you use your conversion factor again. But you want to write 2.5 radians. Okay, so a couple of topics. So unit circle, arc length. Letter C. Next topic, everyone's favorite. SOHCAHTOA. SOHCAHTOA. Yes? I think you learned this in geometry.
Yes.
Yeah. So SOHCAHTOA. So what that stands for is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And those are for what kind of triangles? Triangular, yep. Triangles with 3 sides, good. Right triangles, thank you. That's what I was looking for. All right.
Good job.
Right? Oh, you did?
Good job.
Oh, I heard triangles, yep. Okay, so here's theta. Theta is our central angle again. And this is x, because it goes along the x-axis, and y goes up. And we'll call this r. And so we can say that the sine of theta for that triangle right there would then be SOHCAHTOA, opposite over hypotenuse, so y over r. If you're on a unit circle means the radius is what? 1, and so that's why your sine value is just y, because your radius is 1. All right, then cosine would be x over r. Cosecant. Remember cosecant?
Yeah.
Cosecant is r over y. It's the reciprocal. As long as y is not 0. So cosecant is undefined at places. Do you remember the graph of cosecant?
No.
It's like the sine wave, but then you flip it out and you draw asymptotes. And then secant of theta is r over x, as long as x isn't 0. If x is
Secant opposite of cosine, right?
reciprocal. Mm-hmm. Yeah. They go together. Like that. Mm-hmm. And then we also have tangent. And tangent would be TOA, opposite over adjacent, as long as x is not 0. And then its reciprocal, cotangent. Oopsie. Cotangent of theta is x over y. All right. It's all coming back to you. So now what we're going to do, remember, are you taking good notes, Camden? Camden is? Yeah, he does. He has good writing. Number 5. Is there like boy writing and girl writing, huh? Mm-hmm. Sexist. It's messy. Mm-hmm. All right, here we go. Given that the cosine of theta is 4/5, we're told this, and that the sine of that angle theta is less than 0, we're going to find all 6 trig functions of that angle. I don't think we're going to have any time to do inverse trig functions today. So if there's anything in the book about inverse trig functions, just skip that and I'll add that on to the tomorrow's stuff, okay? Inverse trig, like remember inverse trig? Sine inverse, like that, or arc sine. Anything like that in tonight's homework, just skip for now, okay? I don't want to go into Canvas and change it. Okay, so here we go. What you want to do is you want to draw a picture. Okay, so draw a picture, and you got to figure out which quadrant you're in. So look up here. Cosine is positive. The answer is 4/5. Okay, sine though is negative. So what quadrant gives me cosine positive but sine negative? 4. Okay, here all of them are sine, tangent, cosine. So if sine's negative, it can't be that quadrant or this one. And if cosine's positive, it can't be that one. So there's only one quadrant. So here's what you do. You draw a triangle, and then theta is your inner angle. And then cosine of theta is adjacent over hypotenuse. So the adjacent side is 4. The hypotenuse is 5. This is the old what? 3, 4, 5 triangle. There it is. But don't forget 3 is what? -3. Ooh, that gets some of you every time. Because it's hard. It's like, what? A side of a triangle is negative? Okay, so now let's find the rest of them. Let's find the sine of theta. So now you go back to your triangle. Sine is opposite over hypotenuse, and we were expecting it to be negative because it's in quadrant 4. And cosecant is going to be the reciprocal of that, -5/3. Okay, they gave us cosine already. That was nice. Cosine is 4/5, which means secant is the reciprocal 5/4. And then tangent of theta, TOA. Opposite, so here's the opposite side over the adjacent side, and then cotangent is the reciprocal. Okay? You remember doing those two?